Hi everyone, it's Mr. Masuri here. We've got one last example problem to show you how to use the formula for acceleration. Unlike all the other problems we've done, this one involves an object that's slowing down. Remember, acceleration is not just speeding up. It includes slowing down or changing the direction of your motion. Now, we will never do a problem in here that involves changing the direction of motion, but we will sometimes do word problems involving objects that slow down. So let's take a look at how this goes. While coming to a red light, Karen slows down to a stop from 12 meters per second in 4 seconds. What is Karen's acceleration during that time? Let's start the way we always do by making a list of what we know. So, it says she slows down to a stop from 12 meters per second. Now let's be very careful here. Is that 12 meters per second how fast she's going at the beginning of the problem or how fast she's going at the end of the problem? Well, if she's slowing to a stop, that's how fast she is going at the beginning. That means that 12 meters per second is our VI, because that's how fast she's going at the beginning. Then our VF, well, it says she slows down to a stop. It doesn't include an actual number there, but if she stops, her final velocity should be equal to 0, correct? And then finally, it says in 4 seconds, so that is our time. And it asks for Karen's acceleration, which means our question mark here will be A. So that's a list of what we know. Let's go on to our next step, writing the original formula. Since we're finding an acceleration, the formula will be A equals V little f minus V little I all over T. Our next step is to plug in the numbers. We don't know A, so we leave that as A. Then we've got VF. Now be careful here. VF, which is 0, minus VI, which is 12, all over T, which is 4. And then it's time to solve. Now let's be very careful. When we solve, 0 minus 12 gives you negative 12. Don't forget that negative. And negative 12 divided by 4 gives you negative 3. And then we need our units. For an acceleration, the units will be meters per second squared. So our acceleration equals negative 3 meters per second squared. When students do a problem like this, sometimes they get bothered by that negative. But think carefully. If an object is speeding up, the acceleration is positive. And slowing down is the opposite of speeding up. That means that whenever an object is slowing down, the acceleration will be negative. Remember, a negative acceleration does not mean going backwards. Going backwards is a negative velocity, not an acceleration. But a negative acceleration means that the object is slowing down.